Hello. Can I get a better idea of who is in the audience? Because I have a lot of technical aspects and then some medical stuff as well. So I just want to make sure I'm talking to the right people. How many of you are technical engineers, data scientists? Whoa, I'm going to get a lot of questions. And how many are medically related, trained, and business? Okay, bit of everything. Awesome. So my name is Elina. I'm a data scientist and a biomedical engineer. I'm just finishing off a PhD at Oxford University and have also been working on my own startup, which is called Fibrous, and effectively is developing a mobile-based diagnostic platform that uses AI-driven algorithms to perform point-of-care diagnosis and monitoring of health conditions. But before I take you into the technical side of things, I just wanted to give you a bit of a background into where the motivation for this work came from. So, as we all know, the last few decades have been very transformative for many aspects of our lives. Technology has proven to be a really powerful tool when it comes to democratizing access to services. So if you look at information, knowledge used to be locked up in libraries, only accessible for people that had the resources to get to them. Nowadays, you can find information everywhere. Similarly with communication, we used to rely on institutions like post offices or the infrastructure for telephones to speak to people that are at the other end of the world. We no longer need that. Money, banks used to be the institutions that deal with our payments. In a lot of developing countries, we can see leapfrogging when it comes to payments, mobile payments, and nowadays you can find people paying for their groceries with their mobile phone without ever having a bank account. The situation with healthcare, I dare say, is rather different. We obviously have advanced tools that have popped up when it comes to the next generation of MRI machines in hospitals, but we still have heavily institutionalized delivery of healthcare. And what I mean by this is that we have this expert called the doctor, no offense to any doctors in the audience, that we still rely on when it comes to accessing these services. This creates a lot of challenges in terms of access. So if you look at low resource settings, where we have a shortage of these professionals, it automatically means that you have this filter that prevents people from accessing services. And that's not surprising, given that the World Health Organization operates under this definition of what health is ever since 1948. So they say health is a state of complete physical, mental, and social well-being. What this automatically applies is that many groups in society are straight away denied the attainment of this concept of health. So if you are an elderly person living with a chronic condition, at least one of them, as most of them are nowadays, or if you're a disabled person, or if you're a child in a low resource setting, you straight away can't attain health because it needs to be complete physical, mental, and social well-being. And there have been a lot of discussions that have emerged in the last decade around this. Is that really what our health system should aspire for? And as innovators, is that what we are trying to create? Tools that keep everyone entirely healthy. And The Lancet published a really interesting editorial that proposed this definition. Health is the ability to adapt to one's environment. It is not a fixed entity, and it's defined by the individual's evolving needs, functional needs. So as innovators, rather than trying to fix people, we're trying to provide them with the tools to adapt to their functional needs. That straight away shifts the focus for elderly people, for example, where we're no longer trying to cut them open and fix them up. We're trying to provide them with the tools to cope with whatever conditions they're suffering from. So I passionately believe that data science and modern technology has a really important role to play in this, especially when it comes to democratizing access to healthcare. And this is why I have been working on this innovation called Fibrous, which consists of a mobile health platform, so an application which communicates to off-the-shelf tools. So existing hardware like, put them in my pockets, like a digital stethoscope, for example, or a pulse oximeter. So a lot of these hardware gadgets that the medical device companies have been producing that are currently not accessible to people simply because they require a doctor to interpret what they produce. So what the platform does is it takes the signals onto your mobile phone. It uses signal processing and machine learning algorithms to extract important symptoms, and then it fuses those symptoms to derive a diagnosis. That's basically a summary of what I just said. And the specific problem I have been obsessed with and have been working on when it comes to delivering this solution is pneumonia. So back in 2013, I was working at the World Health Organization and was very surprised to learn that pneumonia is the #1 killer of children. It actually kills more children than HIV, tuberculosis, and malaria combined, which is not something you hear every day. Especially when most of us realize that we often get pneumonia. It's not an uncommon condition that we don't know how to treat. 95% of the mortality in children is concentrated in developing countries where there is poor access to healthcare facilities. But at the same time, pneumonia is also the main cause for a lot of healthcare expenditure in the elderly in developed countries. And really the root of the problem is in the fact that it's very complex to diagnose. If you think that your 5-year-old has pneumonia, you need to take them to the GP. They might have to examine them multiple times, take measurements with various tools. So they'll most likely use a digital, or a stethoscope, not a digital one, a stethoscope, a pulse oximeter. They might send them to the hospital. Then an expert pulmonologist is going to listen to their chest, do their magic, and eventually tell you they have or they don't have pneumonia. There is no one simple measurement that you can take at home to get to this diagnosis, which automatically means that if you live in low-resource settings, let's say the slums of Mumbai, you don't have that access to care. And this is just a table that shows you the different measurements or symptoms that you can try measuring, and then the sensitivity and specificity of diagnosis that will come from it. So as I said, my motivation is to develop a solution that's applicable both to the elderly and the children, but for the purposes of this talk, I'm going to focus on the children. So the innovation of what I'm doing is twofold. One is uncovering insights from the signals that these devices generate. And the second one is fusing symptoms into diagnosis. And for this, I worked with different data sets from across the globe. One of them came from the Gambia, a study of 1,500 children. The other one was my own study that I ran in 2017 in India across 6 months, where we had 1,300 children being diagnosed with the tools by different users. So we tried giving the tools to doctors in the hospital, to nurses, as well as very minimally trained healthcare workers, which would be the proxy of parents in this country. And here I'm just going to give you a quick idea of what the innovation actually generates. So if you look at the digital stethoscope, for example, it didn't used to be digital, so it used to be this tool that only a very highly trained doctor can use and apply it to your chest, and then they need to be able to identify certain pathologies in the signal. There are things called crackles and wheezing and grunting, and they give them these fancy names, and only if you have 10 years of training you can actually decide whether a child has crackles or not. What the study in India demonstrated was that if you record these signals with a digital stethoscope and then give them to 8 different doctors to annotate and tell you what's in them, they're going to give you different answers, which makes me very worried if I'm the one whose data is being interpreted and whose diagnosis is being based on that. So for starters, this gold standard is completely useless. What that means is that you can't develop algorithms that rely on that gold standard. Hence, what I do is develop algorithms that look for new biomarkers in the signal. things that we can actually trust are in the signal, and we can link to the final diagnosis, in this case, of pneumonia. And just to give you an idea of how our annotate is performed, we did two things. One is compare how they perform against the other annotators, but also very sneakily gave them the same data, so they don't even agree with each other. With themselves. So given the same sample twice, they would give it a completely different label. Not to scare you off if you have a respiratory disease right now. So the approach that I'm describing, which doesn't rely on these arbitrary clinical labels, but rather focuses on different markers in the signal and their classification, is illustrated here. And as you can see, don't have to care too much about these specific numbers, but it achieves more than 90% sensitivity and specificity. The other thing that we could do with this type of data is start looking at things like severity, which is very important when it comes to making clinical decisions. And here, using signals generated from a couple of devices, we perform fusion to effectively classify the disease, as well as decide whether the case is severe enough and whether or not it should be referred to a hospital as a result. The other very important aspect of this is that we can even start looking at things like etiology. What I mean by this is whether a disease is viral or bacterial, because that influences treatment. At the moment, all cases are given antibiotics, which shouldn't be the case because at least 50% are viral. But there is no test that can reliably tell you whether or not a child should receive antibiotics. So for these purposes, again, we use machine learning to fuse this information and extract the diagnosis. In terms of the journey, so I've consciously chosen to develop some of this work through academic research, because it gave me access to a lot of data sets that are very difficult to generate or collect from a startup perspective. And then more recently, I was awarded a prize, by the Children's Prize Foundation, which would then fund the implementation at scale in India later this year.